Hello everyone, welcome to Codedynamics. In this video, we are going to see how to do multiple linear regression using Python. For this, I have a dataset called multiple linear regression dataset.csv. I will give the link in the description, you can download it. So here in this data, we have 5 columns as you can see. The first column is R&D spend, the second is administration, the third is marketing spend, the fourth is state, and the fifth is profit. By looking at the dataset, you can know that this is a dataset from a company which is spending on R&D, administration, marketing in certain countries like India, Canada, USA, and Germany, and are making some profit. Right, so the dataset is something like if you spend this much on R&D, this much on admin, this much on marketing in India, the company is making this much profit. Similarly, if you are spending this much on R&D, this much on admin, this much on marketing in Germany, they are making this much of profit. So that is the overall data, and here we have something like 500 rows of data. This is a synthetic data. This does not represent any real-time data. And here we have 4 countries: India, Canada, USA, and Germany, and we have 3 independent variables and 1 dependent variable, which means like these 4 are input and this is like the output which our model should predict. Okay, so to classify this countries which are like a string and not numbers, we are going to use something called one hot encoding. So what is one hot encoding? See, if it is something like these numbers, we can pass in and we can predict something, right? Like just like what we do in normal linear regression. But if it is like a string, like a variable or something which is not a number, then what do we actually do? So how do we proceed about that? So we have something called one hot encoding, where we take in the variable names. If it is like repetitive, in our case it's always just India, Canada, USA, or Germany. We know that only these 4 exist in the data set, so we can assign IDs to them. So let's say red is 1 and blue is 2 and green is 3. Then what we are going to do is we are going to make a truth table something like this. So if the data set is talking about red, then red will be 1, other 2 will be 0. Similarly, if the data is talking about blue, then the column of blue will be 1, the other 2 will be 0. And if it is green, obviously green column will be 1, other will be 0. So in our case, what will happen is if it is India, then the column of India will be 1, other 2 will be 0. So if you take this specific row, what will happen is this single column will be split into 4 columns. So which can contain either 1 or 0. So let's say India is 3. So in 3, what will happen is 0, 0, 1, 0 will be there. The third column will be 1, which means it is India. Likewise, Canada, let's say it is 1, then the first column will be 1, then 0, 0, 0. So that is what will happen. Similarly, for USA, it will be 0, 0, 0, 1 because USA is last. It is all done in alphabetical order. In our case, it's Canada, then Germany, then India, and USA. So in terms of Germany, if you take the 14th row, it will be 0, 1, 0, 0. So this single column will be split into 4 columns, and this is what is one hot encoding. We will be using this as a library from scikit-learn, and let's get into the code. So initially we have to import some libraries. So let's import numpy as np. Let's import matplot library dot pyplot as plt. Then we are going to import pandas as pd. Then we will import sklearn. So sklearn is basically scikit-learn. Under that we have compose. So we have to put from sklearn.compose import column transformer. Since one hot encoding is going to get affected into the columns, we have to import the column transformer. Then from sklearn.preprocessing, we are going to import one hot encoder. Now run this cell. Now we have to load the data. So you can download this data and keep it in the same folder as this Jupyter notebook file, or if it is a collab, you can upload it directly there. Then what we are going to do is we are going to put it under a variable called dataset. I'm going to use pandas to read it. So we are going to use read CSV. Inside this, we are going to pass in our file name, which is like multiple linear regression dataset.csv. Then if you want to view the dataset, just type dataset and you will be able to see that there are 500 rows and 5 columns, just like what we have here. So it is correct dataset, but it is not so good looking. So what we will do is we will put dataset dot head, which will give just the 5 first rows and all the columns. So we have this. Just in case if you want to see what is the shape of it, you can see dataset dot shape, which is 500 comma 5, right? So now let's get back to dataset dot head. Now we have to split the entire data into x and y, which is like the independent and dependent data. So in this case, the first 4 columns are independent and this is like dependent. The value of profit depends on these choices, right? So these are independent, which is x, and this is the prediction which we are going to do. So this will be y, right? So we are going to split it into x and y. So for x, what we are going to do is we are going to take the data set and do something called the ilog function, and this takes in 2 parameters. One is the rows which we need, and the second is the columns which we need. Okay, so the first thing, rows, we need all the rows, right? We need all the data. So we will take just the column which colon, which will give all the rows. So for column, we are going to slice it. So it starts from the 0th column. Here it is the 0th column. Then we take the first, the second, and the third. So it is from 0 to 3, or this is the -1 column, which is like the last column in terms of Python. So whenever there is a string, if you specify the last one, when you are taking the slice, it will take in -1. So if I take just like 0 to n, then what will happen is the actual data will be from 0 to n-1 only. So what we are going to do is take all the rows and I'll specify the last column, then it will take only till the second last column. So that is what will happen. So we are specifying that, and then we have to put dot values so that it doesn't take the heading, it will take just the values. So we have to specify dot values. Then the second thing is dot ilog. Then we need all the rows and just the last column, right? So we will specify -1. In this case, there is no slicing. So it is just n, not n-1. Only when we are slicing, it will be n-1. So it will be dot values. Now, if you want to see what is the shape of x and y, you can do this. So you can see that x is 500 comma 4. So we have 4 columns, and y is 500 comma nothing, which means 500 comma 1. So we have only one column. Let's see what is there in x. Let's just print the first 5 rows. You can see we have the first column, the R&D, the admin, and the marketing, and the state, which is like the country. So that is the same for all 5 of them. Similarly, if you take y, we have just the 5 values, which is the profit values for the first 5. So let's just keep it to x, first 5 rows, or let's keep it to shape, okay, so that we can use it later. Okay, now the x shape is 500 comma 4 and y shape is 500 comma 1. Now let's start encoding the data, just like what I had explained already. We are going to do the one hot encoding. So for that, we are going to use something called the column transformer. So the column transformer takes in 2 parameters. So if you want to see what the documentation is, either you can go to Google and search, or click on this and press shift plus tab. So it will give us. So the column transformer is taking multiple values like variables like the transformer, the reminder, the sparse threshold, and so on. But for us, we just need two things. One is the transformer, Okay, and the second thing is reminder. So we are going to type reminder equal to. Okay. So now what we are going to do is that for the transformer, we have to mention what the transformer is going to do. So what is the transformation which we want? It is the encoding, right? So we have to mention encoder, comma, what is the encoder? We need one hot encoder. So we will specify that it's a function. So these parentheses, and which column do we need to encode? So in our case, it's the third column. So it starts from 0. So it's the third column, and see here it's 0 1 2 and 3, so the third column. And then we have to specify what we are doing for the remainder. So for remainder, we are just going to pass through, which means it will not do anything for the remainder of the columns. So make sure to put a comma here at the end, otherwise it will throw out an error. So we have mentioned what is the transformer and what we have to do for remainder of the columns. Now let's store it inside a variable ct. Now if I print CT, it will give something like this. So what is a column transformer doing? It is taking in the transformer and something for pass through, and you can see that it's a one hot encoder is the encoder, and for reminder we are just passing through. Now we are supposed to use this CT, right? And we have to pass in the X. So how do we do? So within CT we have something called the fit transform, and for that X is our input. So X is our first four columns and we are going to pass in as the input. Okay, now we are supposed to give it and it will give us some output, right? So we are going to store it as an array, numpy array. So np dot array, so whatever data this returns, it will be converted into a numpy array, and let's store that into X. Okay, and make sure to run this cell only once, otherwise every time the X will be modified, and for that modified X you will be running the one hot encoding over and over again. So make sure that you are running this only once and not more than that. Okay, and in the next cell we can see what is the X shape. Now if you see, instead of 500 by 4, like here we have 500 by 7, because the first three columns are unchanged, but this column is split into four more columns, right? So the 3 plus 4, we have 7. But there is one small change in the dataset, like the encoding is saved in the first few columns and not in the last. So here we have it as the third column, 0 1 2 3, right? So technically fourth, but in terms of Python it's third column. But after we do the encoding, it will all come to the start. Like let's maybe print just the first thing. So if you take the first data, we have 0 0 1 0. So as we already spoken, India is alphabetically third, so it's 3 0 0 1 0. So it's in the third, right? And we have the corresponding values followed by that. And similarly, let's say if it is Germany, the 14th, right? And it has to be 0 1 0 0 as per our understanding. So if it is 14, we have to pass in 13 because it's minus 1. Yes, the second column or 0th first column is basically 1, which means it's Germany, and we have the corresponding values 42467179909. You can see that 42467179909 is there. So we have got the correct data and correct understanding. Okay, now that we got the encoded data with an X, we are going to split them into training and testing data sets. For that, we are again going to use one sklearn library called model selection. So from sklearn.model selection, we are going to import train test split. Okay, now run this, and we are going to do something like this: X train, X test, Y train, Y test is equal to train test split X comma Y. So those are the inputs, right? We are going to give X and Y as input. Now if you click on this and press shift tab, you'll be getting the documentation. So you can see that it takes in the arrays. Then we have to specify the test size, train size, and random state. And maybe if we want shuffle, we have to mention the shuffle also. Okay, so what we are going to do is we are going to give the test size, and let's put 0.2, which means it will take 20% of the entire data for test split. 80% will be remainder in the train split. Okay, then let's put shuffle equal to true and the random state equal to 0. Run it and let's open a new cell and let's see what is the shape of train and test. So the entire data has 500 rows, so 80%, which is like 400 rows are in train, and 20%, which is like 100, or in test, and the columns remain the same because it's from the same data. So this has been shuffled, so it's not like the first 400 and the last 100. It has been shuffled and it will just change for the training and test. It will be like uniform. It will not be this first 400 and last 100 on top. Okay, now coming to the training, the multiple linear regression model, we are going to import a library from sklearn dot linear model import linear regression. Okay, so here inside this we have something called the linear regression class, and for that we have to make an object. So we are going to name it regressor, and let's just print regressor now. So you can see that linear regression is a class and we have created an object for it. So we are going to pass in something called the fit. Yeah, sorry, it's regressor dot fit. For fitting we have to pass in our x train as well as our y train. Okay, now after doing that, this will turn on like blue color. Okay, now you can click this and you can see that it says it's fitted, and if you click this it will take you to the documentation for linear regression. So we have fit our model. Now let's make our prediction. So for prediction, let's put it inside a variable called y predict, and let's call our regressor dot predict, and let's pass our data, which is like x test, which will be our testing data. Okay, now if I print ypred, you can see that it spits out some data, and if you see the shape, it will be 100 comma 1, right? Because we are passing in 100 test x, so we will be getting 100 predicted values, which are like the profits predicted. So if you can see that this is all like in 8 decimal precision. To put it in 2 precision, what we can do is np dot set print options, and inside that we can put precision equal to 2. Now we can see we have only 2 precision and it's much neat to see. So now what we are going to do is, we don't want this actually. Let's just run the cell, create a new cell. So here what we are going to do is, we are going to create 2 new variables called y predicted rs, for which means like reshaped, and y test rs, again this is reshaped. So what we are going to do is, when you like printed shape of this y pred dot shape, you can see it is 100 comma nothing. It's 100 comma 1 technically, but it says like 100 comma nothing, right? So to solve that problem, what we are going to do is, we are going to take our y predicted data and we are going to reshape it. So it's reshape, then we have to pass in what is the shape of it, right? So for the shape, it has to be 100 comma 1. So what is 100? It is basically the length of y predicted. So 100 comma 1. So it will not be like hard coding. We'll pass in just the variables, and here instead of y pred we need y test. Similarly here the length of y test will come. Now if you print the ypred rs dot shape comma y test rs dot shape, you get 100 comma 1 and 100 comma 1 respectively. So why did I even do this, right? So let me tell you why I did that. Now if we print y predicted rs comma y test rs together, you can see that we have some 100 values here and some 100 values here. Now if we want to compare the predicted to the test, we need them side by side. If we have like corresponding ones, we can visualize it better, right? So what we can do is we can take the numpy concatenate function, which takes in two things. So one is our input arrays, so the both are like arrays, numpy arrays, right? So we have to give both our arrays. So in our case it's ypred rs and y test rs. Then we have to specify which axis is getting concatenated. If you open, it is asking us which axis, right? So what we are going to do is we are going to specify one, which means we are going to concatenate in columns. If you specify 0, it will concatenate into rows. So let me first put 0 and show you. And before that, let's store it inside y concat. Okay, so if I concat, it's all single array now, but it's stacked row by row. Okay, first the y pred rs will come, then the next y test rs will be stacked underneath. But if I put one here, you can see it is stacked side by side. Right now it's much easy to compare. So for the first test, the actual value was 300,000 something, but the prediction was 275,000. And similarly, if you see here, the actual was 191,000, but the predictor was 178,000. So we are able to compare them right now. If you just print the first five values, maybe you are able to see that there is some slight difference, but it's mostly correct. But what does mostly actually mean? So what we are going to do is we are going to calculate our mean root mean square accuracy and root mean square error. So how do I do that? So first what we are going to do is we are going to take y predicted numpy dot array, and we are going to pass in y predicted. So we are just passing now y predicted and creating the normal array as a numpy array, and we are going to flatten it. Okay, and similarly for y test, we are going to pass in our y test and flatten it. Okay, then what we are going to do is we are going to calculate the error. So what is the error? The error will be y test minus the y predictor. So that will be our error. Similarly, the squared error will be error power 2. So the broadcasting will be done by numpy. You can see that each of the elements have been squared. If you just see error, it's just values. It will have both positive and negative values. But if you put squared error, since it's a square, it will all be positive, and it's also squared. Each of the element is squared. That's called broadcasting. It will be done by numpy. So now if we want to calculate the root mean square error, first we have the square error and we have to take the mean of it. So numpy dot mean. Now we have mean of the square error, so we have to take the square root of it. So numpy dot sqrt, so it's the square root. Now we want to store it inside our root mean square error, right? So it will put at rmsc is equal to this, and let's print out rmsc. So it is like multiple decimal points. So let's round it up, round. So it will also take in how many digits? 2. If we put that, we are getting rmsc. Nice. So now what we are going to do is let's put a comment. This will be rmsc. Similarly, we are going to calculate our rmsa, which is like the accuracy. So what is accuracy? So if you see here, we have error, right? So in our case, the error is this, right? And if you divide this entire thing divided by y test, right? So whatever values you are getting, it's the percentage, or like how much error percentage is there. What do I mean by that? Let's create a new cell here. Let's say the actual value is 2, but I predicted it as 5. Okay, so it's 2 minus 5. Now when I want the, it will be like minus 3. That's the error between those two. Now if I want the percentage, now I will divide it by the actual value, which is like the 2. So I have 1.5 percentage of error. Now let's just swap. The actual value was 5 and the predicted was 2 and the truth is 5. Then I have 0.6 of error. So that ranges between 0 to 1, right? So if we have to convert it into percentage, we will multiply by 100. But what is the accuracy? So if this is 0.6, which is the error, then the accuracy will be 1 minus this value. So it's like 1 minus the error will be the accuracy, right? So this error can be either positive or negative, like in the previous case. If the actual was 2 and if I had predicted 3, then the value would actually be 0.333. So that's the error. So it's minus 33 percentage. So what we can do is, if we put ABS around it, it will just give what is the percentage instead of the negative or positive also. So similarly, we are just going to bracket it with ABS. Right now we have everything as absolute, and that would be our error values, right? So it will be percentage if you multiply by 100, but as of now it's just error. So if you want to convert it into accuracy, you just put 1 minus that error. Now we have everything as accuracy. Now if you multiply this entire thing by 100, you have the accuracy percentage. So now we can go on and put it under the variable name accuracy. Right now, if we want to calculate root mean square accuracy, then it's the same treatment just like our RMSE. First, we have our accuracy. Now we want mean of this. So we put np.mean. Now we have the mean of accuracy, but we want mean of accuracy squared. So now we have mean of accuracy squared. So we will get numpy of sqrt with this. Now that would be square root of mean, so which is like the root mean square of accuracy. So we have RMSA, that's what we wanted. So now again let's put this under round. Okay, now let's print RMSE and RMSA. So we have 92 percentage of accuracy. Okay, sorry, I did not mention minus 2 here. So it's 92.19% of root mean square accuracy, and we have 18,882.24 root mean square error. Now if we want to print it more nicely, what we can do is we can put print accuracy is equal to, okay, let's do like this. F accuracy is equal to percentage F percentage comma RMSA. Okay, we have to put percentage here. Okay, so if we put dot 2 here, we'll get just two decimals. Okay, now let's print RMSE is equal to now RMSE. Okay, we have our RMSE and our RMSA. Now let's plot what is the predicted versus the actual. Okay, so let's first set the background to dark because I like it in dark background. Style dot use, I'm going to mention it as dark background. Okay, now what we are going to do is, first we have our y predicted rs. So let me show it. Predicted rs dot shape. So we have 100 rows here, so we have 100 values. So that would be in our y-axis. In x-axis also we need some 100 values so that we can plot against that. So how do we create the x-axis? For that, what we are going to do is I'll make x-axis is equal to np dot a range. Here we are going to pass in the length of y predicted or y predicted rs. It doesn't matter. Now if you see x-axis dot shape, we have 100 comma 1 again, so both are compatible. Now we can start plotting. So it's plt dot plot x-axis comma y predicted rs or y predicted, it really doesn't matter. Then plt dot plot x-axis comma y test rs. Okay, then we have our plt dot y label, and our label would be price. Then we have plt dot legend. So in our legend, the first thing is our predicted, then the second thing is our actual. Okay, then we put plt dot show. Yes, we are getting a plot, and we can see that it's mostly correct, right? It's 92% accurate, like our number says. So the green kind of line is the predicted values, and the yellow is the actual. So now we are able to see it as a graph. I hope you learned something in this video, and that's it for this video. If you want to see more videos like this, kindly subscribe and drop a like maybe. And if you have any suggestions, something I could have done better, you can feel free to drop down in the comment section. See you in another video.